My project's all about signals within a circuit that act in a chaotic way and how to take these and use these in an encryption that MI5 or GCHQ might use later on when encrypting their data. I've always liked to be able to mix experimental physics and theoretical physics, and there's a lot of maths to do with encryption, and also there's a lot of hands-on experimental physics when it comes to creating this circuit and using the oscilloscopes as well. Yeah, we do get a huge amount of support from our supervisors, and also one main thing here at Hull is that it's an open door policy. So if I ever need help, I can always go down the corridor and get it from my supervisor himself.
My project is synthesising cadmium selenide nanoparticles inside fluorescent bacteria. We synthesise the nanoparticles inside the bacteria. That light then excites the nanoparticles for them to emit their own light. I chose this project because it's never been done before, which is obviously really exciting. You get to try out a new area of science, and that's one of the reasons why I study physics, is because I'm interested in learning something new. The supervisors and your PhD students who you work really closely with during your project, they train you up to use lots of different new equipment. You learn lots of new skills. The really exciting thing about my project is having the opportunity to work in the biology department. So learning to grow bacteria, learning to work in a completely different lab, and learning a completely different new set of skills.
My project is string theory. More particularly, it's a certain aspect of string theory called supersymmetry. I chose my project because I've always been more interested in the theoretical side of physics. I find it exciting because I'm actually getting to do new physics and new maths that I've never had any chance to come across before. I receive a lot of support from my department. I have weekly meetings of about an hour with my supervisor. When I started my project, it was just the title of string theory. But once I'd actually got into it and I started to learn more about string theory, I then got to decide which aspect I wanted to go into.
My project is looking into the fabrication and optical characterisation of card-stand biogratings for use in biosensing. So it includes looking at spin coating, methods of optical imaging, and use of a high-powered argon fluoride laser, which was intimidating to say the least. So when this project was suggested to me, I was very nervous. Experimental's never really been my forte. I took the challenge, and I'm very glad I did. I'm really enjoying seeing the actual application of our work rather than just what could be happening on paper. At the University of Hull, we do have a very well-established laser research group. So being here and doing research into lasers is very exciting, just because the staff, already being so friendly, are just so enthusiastic about the topic. Well, when I was originally applying for university, I would have never imagined myself doing an experimental master's project. To future applicants, I'd just say keep your options open. Don't start limiting yourself too early. Keep as broad range as you can until the very end, and you never know what you'll enjoy.
So my project is using integral field unit spectroscopy to look at galaxies. So that's using a special type of imaging technique to look at the rotational effects of galaxies. Okay, I chose my project because I'm interested in cosmology and astrophysics, and the idea of being able to look very far back into the history of the universe and look at the properties is very exciting to me. So I receive a lot of support from my personal tutor and supervisors, as well as the PhD students. So my project sets you up quite well to do a PhD, so you learn a lot of research skills and you become more familiar with the research environment.